All right, we are here to do a walkthrough of practice quiz number 2 for LT7 polygons. Starting at the top, we're going to label our parts of this polygon. This is a pentagon, 5 sides. So, starting with the apothem. The apothem is a segment that goes from the center to one of the side lengths. It is perpendicular, so look for that right angle. So the apothem is number 2. It's this segment connecting the center to the middle of one of the side lengths. It's perpendicular. Look for the 90-degree angle. The central angle is an angle located at the center. Again, here's the center. Where's the angle? Number 5. The exterior angle is the angle located outside the shape. So which angle is outside? That's this one up here. Exterior means outside, so that's number 1. Interior angle. Interior means inside. Which angle is inside the shape? Well, here's an angle. It's inside the shape, so it's number 6. The radius is a segment that connects the center to a vertex, a corner of the shape. So which segment is that? That's this one, from the center to a vertex, number 4. Lastly, a side length, number 3, one of the sides of the pentagon. That's it for 7.1, labeling your parts. All right, down. Find the indicated angles for a regular septagon. Now let's think about septagon. What does that mean? That means 7 sides. We're going to look at that shape right there. So to find the measure of one central angle, we know all the central angles add up to 360. There are 7 sides. So we're going to split that 360 into 7 parts and get 51.43 degrees. All right. Next step, the sum of the interior angles. What is the sum of the interior angles? Now for that, think about how many triangles fit inside of it. 180 times the number of sides minus 2. So 180 times 5 equals 900 degrees. Again, there are 5 triangles that we can fit inside here. Each triangle has 180 degrees. They add up to 900. For the measure of one interior angle, we take that sum and we divide it by the number of sides because there are that many interior angles. So we're going to take that sum, which is 900. That came from this part right here. This is the sum. So we're going to take that 900 and we're going to divide it by 7, which is going to give us 128.57 degrees. What do you notice these two add up to? Turns out they add to 180. That works every time as well. The measure of one exterior angle. We can come at this 2 ways. Either 360 divided by the number of sides, which is 51.43 degrees, or 180 minus our interior angle. You get the same answer either way. Okay? These is the same as the central angle, or 180 minus the interior angle. Why? If you look back up here, you can see the interior angle, if I were to sketch it in right here, plus the exterior forms a half a circle. All right, that's standards 1 and 2. Let's go to 3. So for standard 3, if the measure of one central angle is 18 degrees, find the number of sides. Well, we know 360 divided by the number of sides equals our central angle. It turns out 360 divided by our angle equals the number of sides. So 360 divided by 18 equals 20 sides. All right. Number 2, if the measure of one interior angle is 144, find the measure of one exterior. What's happening here? Well, it kind of looks like this. We know the interior is 144. What's the measure of the exterior? Well, look at that picture. What do you know about those two? The interior plus the exterior equals 180 degrees. They form half a circle. So how much is the exterior? Take away 144. You get 36 degrees. So the exterior angle is 36 degrees. Next one, the sum of the interior angles is 1,980 degrees. Find the measure of one interior. What do we need to know? We need to figure out the number of sides. To do that, well, turns out the sum of the interior angles, 180 times the number of sides minus 360, equals that sum. So we can use this to figure out, well, how many sides would this be? Let's solve it by doing the opposite. First step, Add 360 to both sides. So 180n. 1,980 plus 360 is 2,340. 180 times n, what's the opposite of multiplying by 180? Divide by 180. So n equals 13. Are we done? No. We're trying to find the measure of one interior angle. I want the measure of one. So to do that, it's the sum divided by the number of sides. So in this case, the sum is 1,980 divided by 13. What does that equal? 152.3 degrees. And the last one, if the measure of one exterior angle is 40 degrees, find the sum of the interior angles. Again, we are wondering, we need to find n. Why? Because the sum of the interior angles is the number of sides minus 2 times 180. So how do we find the number of sides? Just like we did up here. We already found, given a central or exterior angle, find the number of sides. So we can do 360 divided by 40 equals 9 sides. 40 goes into 360 9 times. So therefore, the sum of the interior angles is 9 minus 2 times 180. 7 times 180 equals 1,260 degrees. That is the sum of the interior angles in that regular polygon. All right, let's move on to the golden standard. Find the area and perimeter of a regular pentagon with an apothem of 16 centimeters. So first step, what do we know about this pentagon? Let's start in the center and let's cut it up and let's draw a triangle right there. Now, what do we know? The apothem is 16 centimeters. So that's this distance right here. That distance is 16 centimeters. Okay. Let's draw this triangle separately. So it's going to look like this. Now, what do we know? This distance right here is 16 centimeters. Okay. Then, what else do we know? Well, it's a pentagon, so we can find the central angle by doing 360 divided by the number of sides. So the central angle is 72 degrees. That angle is right here. So that's 72 degrees. Isosceles triangle doesn't really help us though. What makes all the difference here is a right triangle. So let's draw half this shape. What do we know about it? This angle up top, it's half of that angle. So what's half of 72? 36 degrees. The height didn't change. The height stayed the same. But what are we trying to figure out here? Well, we need ultimately to find the area of this triangle. So we need what two things? The base and the height. We need to solve for the base. How are we going to solve for the base? Well, opposite adjacent. Let's use tangent. Tangent of 36 degrees equals opposite over adjacent. To solve this, multiply both sides by 16 over 1 because 16 is on the bottom. So 16 times the tangent of 36 equals x. X is all by itself. We put that in the calculator, and therefore x is 11.62. Now, let's think about what that means in terms of area here. That means this is 11.62 because that's from the right triangle, and this is also 11.62. So let's redraw this triangle. Here's my isosceles triangle. I know this height is 16. What's the full base? It's 11.62 plus 11.62, which together adds up to 23.24. So now, what's my area? The area of that triangle, so triangle area, is base 23.24 times height, 16, divided by 2. You put that together, the triangle area is 185.92. Is that our final answer? No, that is just the area of one triangle. How many triangles are there? 1, 2, 3, 4, 5. So we need to multiply this by 5. There are 5 triangles in the pentagon. So our total pentagon area is 929.6. Area, 929.6 square centimeters. All right, that's step one. For the perimeter, well, we know this. The side length, that base, is 23.24. That means 23.24, 23.24, 23.24. All these triangles are all the same. So how do we find the perimeter? We're going to take that 23.24, multiply it by 5, because there are 5 sides that are that long. So 23.24 times 5, what does that work out to be? The perimeter is 116.2 centimeters. All right, hope this was helpful. Good luck on your quiz.